Today on How It's Made Dream Cars, the Lucra LC470, a lightweight supercar with heavyweight power. Believe it or not, even though the Lucra LC470 houses a powerful V8 engine, thanks to careful design choices, it weighs less than 2,000 pounds. One of those design choices was the decision to make the entire body out of carbon fiber, which only weighs about 200 pounds. The components of the LC470 are also made of aviation-grade material, right down to the wires and bolts. This results in an exceptional combination of lightness, strength, and durability. Lucra Cars was founded by car enthusiast Luke Richards in 2006. His goal was to build the perfect sports car. In essence, he wanted to find a way to combine the agility of European sports cars with the muscle of American V8s. When a customer buys a Lucra, Richard takes them to a racetrack to introduce the driver to the car. A clever structural design allowed Richards and his team to place the engine near the center of the car. This achieved a weight balance of 53% rear and 47% front for an ideal combination of traction and handling. The chassis design is the key to this optimal weight distribution. Known as a perimeter chassis, instead of running under the engine and the passengers, it wraps around them. This means the designers could position the engine block in the seats wherever they wanted to best accommodate the dynamics of the car. The chassis is constructed of DOM steel tubing. Lucra uses CNC machines to precision cut and bend the tubing before clamping it in a jig. Since the chassis is the foundation of the car, it must be absolutely flawless. Even the jig was digitally designed and cut to prevent manufacturing errors. The welding process can warp a structure out of shape unless it's secured. The jig keeps every component rigidly in place as the welder works. Remarkably, Lucra builds the main body of the car in one shot. They place a 3-layer laminate of carbon fiber inside a one-piece mold and let it cure. When removed from the mold, the result is an extraordinarily strong, rigid structure that could almost function as a monocoque chassis on its own. A technician prepares to create apertures for the dashboard components by attaching a laser-cut aluminum template. He then uses it as a guide to carefully drill out all the necessary holes and guide points. Next, he scribes the perimeter of all the openings with a sharp point. The finished dashboard will feature minimal components. The LC470 has none of those distracting 21st century accessories like GPS navigation, Bluetooth connectivity, or USB ports. The worker now unscrews the attachment points and removes the template, revealing the scribe transfer of the dashboard design. It's ready for the final step. The center holes that he drilled earlier provide a guide for the technician's hole saw. The carbon fiber is extremely hard, so he must exert considerable force to cut each hole. At the same time, he must be extremely careful. Since the dashboard is part of the one-piece body, he's only got one shot at doing it right. Next, the body meets the chassis. Rather than a few attachment points, every part of the chassis perimeter bonds directly to the car's body. Lucra starts by riveting the carbon fiber to the steel, then wraps every joint in more carbon fiber to completely fuse the body to the chassis. To make the complex exhaust system, Lucra works with a company that specializes in doing just that, MagnaFlow of Oceanside, California. The exhaust is key to the car's performance, so it has to be done right. Here, they use precision equipment digitally programmed to make perfect bends in the tubing. MagnaFlow uses stainless steel tubing to make the Lucra LC470 exhaust header. This is because stainless steel is rust-proof, easy to keep clean, and capable of enduring the super hot temperatures of the exhaust gases. Specialized gauges test every parameter of each section of tubing to ensure it's flawless. For the LC470, MagnaFlow builds a component known as an exhaust header rather than a manifold. A header is designed to make the exhaust gases flow at a speed that helps optimize the output of the engine. In a sense, the exhaust header helps the engine breathe more efficiently. A laser cutting machine quickly etches out the flanges for the header. The holes in the flanges must precisely match the diameter of the tubes. In fact, the diameter of the header pipe is a key to its performance. The designers matched the diameter to the engine's capacity. The optimal diameter, together with the smooth bends in the pipes, help maximize airflow. But perhaps even more important to the airflow is the fact that with the header, each cylinder has its own pipe. A skilled welder clamps the pipes into a custom jig and goes to work. This style of header is known as an equal length header. That means that each of the pipes is exactly the same length. This feature ensures that all the cylinders work with equal efficiency. Making sure that all those pipes have exactly the same length and simultaneously fit around each other in a tight space is no easy feat. Of course, the header is just one component of the exhaust system. In this section of their facility, MagnaFlow constructs mufflers from giant rolls of stainless steel sheeting. A massive press pre-stamps the steel with the MagnaFlow company logo at regular intervals. This continuous sheet will be used to form the visible element of the mufflers. Next, a powerful cutting machine easily chops the sheet to the required size. A carefully calibrated rolling device forms the sheets to exactly the right curve diameter, 2 at a time. MagnaFlow will use these newly formed cylinders to make the outer layer of the mufflers. As the cylinders leave the rolling machine, a welding head travels along a track underneath them to fuse them shut with the welded seam. A conveyor system then arrives to whisk them away to the next stage of production. At the core of the muffler is a perforated length of stainless steel pipe. A worker places one in a spinning device that turns the core on its axis. This allows the worker to quickly and easily wrap the length in stainless steel mesh. At the next station, a worker surrounds the wrapped core in a layer of mineral wool. Both the mineral wool and the steel mesh can withstand high muffler temperatures. A compression device squeezes the wool around the core and then inserts the assembly inside the exterior cylinder. A worker then slides the heavy-gauge stainless steel end caps over the sections of the core that extend beyond the outer cylinder. He uses a metalworking hammer to tap them gently into place. He then removes the protective film of plastic to prepare the newly formed muffler for the final welding process. A robot transfers the muffler to the final welding station. To dampen sound, conventional mufflers use a highly efficient technique called reflection, which routes the exhaust through a system of baffles. But reflection also slows down the escaping gases, causing something known as back pressure, which diminishes engine performance. So for a supercar like the Lucra LC470, MagnaFlow uses a different technique called absorption. The sound penetrates through the perforated steel core and is partially absorbed by the steel mesh and mineral wool. While the exhaust note tends to be louder, there's little back pressure to diminish engine performance. Chose to use military specification aviation-grade material. Airplanes have to withstand the toughest conditions. Not only do their components need to be able to endure the hot tarmac of runways, shortly after takeoff, they can encounter frigid temperatures in the jet stream. Rapid temperature fluctuations and constant vibration are enormous challenges for any material. Military specification or mil-spec aviation-grade wiring is designed to function efficiently in any environment. The wires are individually coated with a fluorine-based plastic called ethylene tetrafluoroethylene or ETFE. ETFE is incredibly corrosion resistant. Tests simulating accelerated exposure to weather have shown almost no signs of deterioration after 30 years. Not only that, coating the individual wires with ETFE helps prevent other problems. When wires are bundled together, their signals can interfere with each other. The ETFE coating effectively insulates the wires from each other, eliminating this problem. And there's yet another important benefit to using aviation-grade wiring. It's lightweight. The wires in a passenger jet, for instance, can weigh many tons, so it's important to make them as light as possible. Even the connectors used in the Lucra LC470 are mil-spec aviation grade, specially designed to handle constant vibration and exposure to corrosives. The plugs have been given a coating of gold due to the metal's corrosion-resistant properties. Once completed, the technician lays out each set of wires on a wiring design. Drawn up by electrical engineers, the design provides a precise guide to the Lucra system. The technician uses a heat gun to install a protective sleeve around each bundle of wires. The heat gun, blowing hot air at a minimum temperature of 212 degrees Fahrenheit, shrinks the tubing in place. This tubing protects the wires from abrasion and corrosion. It's especially designed to only shrink one way along its diameter. In other words, it won't get shorter when exposed to heat, just tighter. The fully assembled wiring is called a wiring harness. It's now time to move on to the next stage of production. Lucra conducts rigorous tests of every wiring harness that goes into one of its cars. Technicians use a computer to run the tests, checking to make sure all the wires are conducting properly. They also do load testing, check for continuity, and ensure that the wires aren't interfering with each other. The technician evaluates the systems that monitor the car's fluid levels and the controls for the lights. In addition to these typical functions, the wiring harness also controls the power-operated trunk lid and doors, the pre- and post-catalytic converter lambda sensors, and the drive-by-wire throttle. The harness is so carefully designed, it only takes 2 hours to hook everything up. The Lucra LC470 bears a close resemblance to a legendary 1950s race car known as the Lister Jaguar. But under that sleek old-school body is a state-of-the-art 21st century supercar. Due to the LC470's unusually light curb weight, the designers paid special attention to the suspension. The lighter the car, the more it's affected by its wheel weight. This technician inverts the forged aluminum suspension when attaching it in order to keep the component's weight oriented to the chassis rather than the wheel. That way, when the wheel goes over a bump, it doesn't destabilize the car. Next, the technician attaches the high-performance Willwood brakes, which have 6 piston calipers. The fluorescent green object to the left of the brake is part of a high-tech anti-roll bar that stretches through to the other side of the car. The workers now install a Tremec TKO 600RR 5-speed transmission and bolt it in place on the engine. Lucra is so committed to keeping the car's weight down that it even sources the 12-sided bolts they use for assembly from the aerospace industry. Customers can choose from one of 3 engine options: the Mercedes-AMG 6.3 V8, the 6.3-liter GM LS3, or the 7-liter GM LS7, the legendary engine in the Corvette Z07. A technician threads the steering shaft through the dashboard as a second technician attaches it to the pinion. The steering shaft is a telescoping rod that collapses on impact, preventing injury to the driver. SFI rated for racing, this component is used in NASCAR events. The custom-built header from MagnaFlow now goes on the engine. Thanks to careful design, the pipes curve up and over the steering shaft. Before the exhaust gases reach the muffler, catalytic converters help lower toxic emissions by catalyzing a reaction called redox. Here, a worker attaches the MagnaFlow catalytic converter to the header. A technician now plugs in all the wiring in the engine, including an oxygen sensor. This sensor measures the exhaust gases for oxygen level and helps the engine tune itself for optimal performance. 2 workers install the rear diffuser. This is an important part of the car's aerodynamics. As the car drives, it splits the air. The diffuser helps reunite the air moving under the car with the air moving over it. The front diffuser also houses the car's oil coolers, making efficient use of the airflow around the car. It also draws air over the brakes to help keep them cool. But the chief goal of the diffuser system is to slow and pressurize the airflow before releasing it back into the car's slipstream, leaving as little disturbed air in its wake as possible. A worker installs the seats. He can do it easily by himself because these are lightweight aluminum racing seats. These strong, form-fitting seats are made in Canada. In fact, nearly every component of the Lucra LC470 is made in North America. A team of technicians now bleeds any residual air bubbles out of the brake lines. This is necessary with a hydraulic brake system because while brake fluid cannot be compressed, air can be. That means that the presence of air bubbles can reduce the responsiveness of the brakes. One person pumps the brake pedal and then holds it to maintain pressure, while the others release any bubbles that show up. The car is nearly complete. The workers double-check all the plugs and attachments. Lucra's commitment to weight balance is profound. They even mounted the battery in the trunk on the passenger side to balance the weight of the person behind the steering wheel. The wheels are one-piece aluminum monoblock, forged under pressure to create a dense, hard, light component that reduces the car's unsprung weight. Finally, it's time to test out the newly created car's dynamics. Having parked the rear wheels on a pair of rollers and hooked the car's sensors up to a computer, a driver puts it through its paces. As he revs the engine to full speed, the computer runs dozens of tests, ensuring the car is leak-free, perfectly tuned, and meets all design parameters. Building a race car is challenging. In some ways, building a garden variety street car is even more difficult. But fusing a race car with a street car may be the hardest of all. For one thing, race cars don't need functioning doors. For another, street cars don't need to be able to accelerate from 0 to 60 miles per hour in under 4 seconds. Supercars do. Since the brawny V8 engine has only 2,000 pounds of car to move, the Lucra LC470 can explode from 0 to 60 miles per hour in just 3 seconds. With a top speed of over 200 miles per hour, it's a lightweight dream car with a heavyweight punch.